In this video, we are looking at sets and set notation. First of all, what is a set? Well, hopefully these examples will help you understand what we mean by a set. It's actually quite simple. A set is simply a collection of objects. Now, these objects have a name. They're called elements. Let's take a look at the first one. The set containing only the number 3 is this here. Now, notice we've got the number 3 inside these curly brackets. These curly brackets, or braces, are what we use to show that we're talking about a set. So if we just had the number 3 on its own, that wouldn't necessarily be a set. That would just be the number 3. But because I've put it in these brackets, that shows that I'm talking about the set containing the number 3. Next, we've got the set of even numbers less than 10. So notice again, this is not just a list going 2, 4, 6, 8. I've got that list inside these curly brackets or braces. That's to show that I'm talking about the set of even numbers less than 10. Now, both of these are examples of sets that only contain numbers. But sets don't have to contain numbers. In the next example, I've got a set of functions. Sine of x, that's a function of x. F of x, there's another function. Inverse f of x, that's another function. So here's a set of functions. I could have the set of vowels. In fact, you can have a set of pretty much anything you want. Here I've got a set which has some numbers, it's got some letters, it's got an angle, it's got a negative number, it's got the make of a car, it's got a shape, it's got a triangle. So really, sets can be a collection of absolutely anything you want. And each of these things, remember, is called an element. So this particular set I've got here has 1, 2, 3, 4, 5, 6, 7, 8 elements, and these elements are of completely different types. It's not like in the previous example where I've got 5 elements where they're all letters, or in this example where there are 3 elements and they're all functions. So sets can be really quite flexible, like we see here. There is an important set you should be familiar with, and that is called the empty set. Now, the empty set simply contains no elements. So you could represent it using this. It's just a pair of curly brackets with nothing inside. Or you can use this symbol, which means the empty set. Finally, this example is just to show you that a set can contain an infinite number of elements. The natural numbers are simply the counting numbers, 1, 2, 3, 4, 5, 6, and so on forever. So this set actually has infinitely many elements. Let's take a look at question 1. A is the set of letters in the word school. We need to fill in the blanks. Well, let's start with something obvious. We know that we're going to need the letters S, C, H, and O because they're all letters in the word school. But what do I do with the second O? Well, I actually don't need to include it again because I've already got the letter O, so there's no need to repeat an element of a set. That means I can complete the question simply by popping in the letter L there. So this is the set of letters in the word school. Notice I don't need to repeat any elements, so the O only appears once. You should also note, by the way, that the elements of a set are sometimes called the members of a set. So the set A here has 5 elements, or 5 members, and those members are simply S, C, H, O, and L. Another thing to note is that the order doesn't matter at all. You could have written these same 5 letters in any order, and you'd still get this question correct. Let's move on to question 2. B is the set of letters in the word house. Is H a member of B, or is H an element of B? That's what this symbol here means. It's asking us if H belongs in the set B. Well, let's start by working out what actually is in the set B. Here I've listed out the elements of set B. B simply contains H, O, U, S, and E. So is H a member of B? Well, yes it is. So the answer is yes. Looking at question 3 now, we have some new notation to deal with. This symbol here is the Greek letter xi, and it stands for the universal set. The universal set tells us what all the possible elements are for the context we're dealing with. So in this question, the universal set is simply the set of all 26 letters of the alphabet. That means for this question, we can't have any numbers or functions or angles or shapes or anything else apart from letters of the alphabet being members or elements of any of our sets. Now, before answering these questions, it would help to draw a Venn diagram. The Venn diagram we need to draw should look something like this to start with. This circle is going to contain all of the elements of set A. This circle is going to contain all of the elements of set B. And then I've got a big box around the outside to contain all the other elements in the universal set that are not already in A or B or in both at the same time. So remember, A is the set of the letters in the word school. B is the set of letters in the word house. And we need to fill these in here and then worry about all the other 26 letters of the alphabet. It's often easiest to start with this region in the middle first. This region that I've shaded in is in set A, but it's also in set B. So the letters that need to go in here are those letters that are in the word school and also in the word house. There are 3 letters that fit that bill. We've got S in both lists, we've got H in both, and O in both. So to use proper mathematical language, those 3 letters are elements of both sets, and therefore they belong in here. What I suggest you do next is fill in this region. So these would be all of the letters that are elements of set A, but not part of set B. Notice that this is outside of set B. So what elements have we not used already in this part? Well, we haven't used the C and we haven't used the L. So a C and an L would belong in here. Then work out what letters go here. And then make sure that you fill in all of the remaining letters of the alphabet outside in this part of the Venn diagram. Pause the video and see if you can complete the Venn diagram. This is what it should look like. Notice we've got U and E over here because they are elements of set B. And these indeed are all of the letters in the word house, H-O-U-S-E. We already talked about C and L belonging in set A, but not in set B. And then make sure that you don't forget all of these other letters. The universal set needs to contain all 26 letters. And in this big box, you should find that we've got all 26 letters of the alphabet somewhere in here. But whatever didn't belong to A or B or both needs to belong out here. Let's look at the first part of this question then. We need to list the elements of A intersection B. That's what this symbol means. We're looking for the intersection of A and B. And what that means is we're looking for the set of elements that belong to A and belong to B at the same time. So what elements belong to A and to B at the same time? Well, it's simply these ones in here. So the answer to this question is simply the set containing S, H, and O. Moving on to the second part, we are now looking for the union of A and B. That's what this symbol here means. So we are looking for A union B. What this means is that we're looking for all of the elements that belong to set A or to set B, and that includes those that belong to both at the same time. I've shaded the correct region on this Venn diagram. This is the union of A and B, and it contains all of the elements that belong to either A or to B or to both. So we can write out the set as follows, and we can move on. For part 3, we've got a new bit of notation. we've got a little dash here. Now what this is asking for is the complement of A, and this simply means not A. So the complement of A is the set of all the elements that are not in set A. So if I highlight the Venn diagram to show all of the elements that are not in set A, you will find we have this set here. So everything outside of set A belongs to this set here, the complement of A, or not A. And we can simply list out the elements of this set as follows. And we're done. In part 4, we need to list out the intersection of sets A and the complement of B. So set A is this set here. The complement of B is all of this set outside of B. And the intersection, remember, means that it needs to belong to both of these at the same time. So it needs to belong to A, and it needs to belong to the set that is the complement of B. This is the intersection of set A and everything outside of B. So we can't include this bit, even though it belongs to set A, because we also want to make sure that we're only dealing with elements that don't belong to set B. So this is the region we're looking for. It is the intersection of A and the complement of B. In other words, it's the set A and not B. That means our answer is simply the set containing the elements C and L. In part 5, we are looking for the complement of the intersection of A and B. Remember, this is A intersection B, and because I've got this dash here, that's telling me I want the complement of this. Or, in other words, I'm looking for all of the elements that are not in the intersection of A and B. Now let's just go back a second. We've already worked out what the intersection of A and B is. A intersection B is simply the set containing S, H, and O. And that is highlighted right here. Now we don't want the intersection of A and B, we want the complement of that. In other words, we want everything that's not in this set. So the set we're actually looking for is this one here. These are all the elements that are not in the intersection of A and B, and we simply have to list all of these out in our curly brackets. So notice we've got all of these letters listed here, but we don't have the S, the H, or the O. Finally, on this question, we've now got the complement of the union of A and B. Pause the video and have a go at this one for yourself. Here's the answer. We know from part 2 that this is the union of A and B. Now we want the complement of this union, so we want everything that's not in here. That means what we're actually looking for is this set of elements. So we simply need to list out all of these letters in the highlighted region, and that's our answer. In question 4, we've now got a new set to deal with. We had sets A and B before, up here in the top left. We've now got set C, which contains the letters C, P, and Z. Notice, by the way, that we normally use capital letters to name our sets. So our set capital C contains the elements C, P, and Z. Now, before we can find these intersections and unions and so on, what we should do is draw a Venn diagram again, but this time showing us A, B, and C. Pause the video and see if you can complete this Venn diagram using the information from the top left about sets A and B and this information here about set C. Here is what the Venn diagram should look like. we've got A and B and C arranged in such a way as there's a bit in the middle which is called a triple intersection. It is the intersection of all three sets. Anything in this region belongs to the set A and to B and to C. Now, in this particular question, there are no letters that are in all three sets. We've got S, H and O that belong to A and B. So they're in this region here because they're part of A and they're part of B. But none of these three letters belong to C. So they don't belong in here. The letter C itself belongs to set C, and it's also an element of set A. So it needs to be in A and C, so it goes here, but it can't go in here because it's not an element of B. Similarly, the letters P and Z, they belong to set C, so they need to be inside this circle, but because P and Z don't belong to A or B, we can't put them in any of these regions that I'm pointing at right now. And then all the letters that we haven't already used inside these three sets need to be shown on the outside of them. So we've got our complete universal set. All 26 letters of the alphabet are in here. Let's look at the first part of this question. We need to find the intersection of B and C. Pause the video and see if you can identify the correct region of the Venn diagram that corresponds to the intersection of B and C. Here's the answer. This region is the intersection of B and C. This is the region showing everything that's in B that is also in C. Now you'll notice that this region has no elements. There are no letters in here. So the intersection of B and C, this particular set itself, is actually just the empty set. Now we most often use this symbol for the empty set, but you could also use a pair of curly brackets with nothing in between. In part 2, we are looking for the union of the set which is the intersection of A and B and the set C. Now we already know what the intersection of A and B is. That's everything that's in set A and set B at the same time. So that is this region here. Now we want the union of this whole set with the set C. So the set C is now highlighted too. And remember, the union means we want everything that's either in here or both. So we want the entire highlighted region that you can see. So the answer to this question is as follows. Now in part 3, we are looking for the intersection of the union of A and B and set C. Let's deal with the bit in brackets. We know that the union of A and B is simply this region highlighted. That's everything that's in set A or set B or both. What we want now is the intersection of that set with set C. So we want everything that's in this set that is also in set C at the same time. So what we really want are just these bits down here. So I'll remove all the bits of this set that we don't want, and we are now left with the set that we're looking for. This set here is simply the intersection of A union B and the set C. And the only element it contains, as you can see, is this letter here, the lowercase, or the small letter C. Moving on to question 5, we are looking for the probability that a letter chosen at random from the universal set happens to be a member of each of the following sets here. Let's look at the first question. So we want to know, what is the probability that a letter chosen at random from here belongs to set A? Well, A is that set there. You can see it has 1, 2, 3, 4, 5 elements. So the probability is going to be 5 over 26, or 5/26. Pause the video and have a go at the next two questions. Here are the answers. Here is set B. You'll notice that B also has 5 elements, so the probability of picking a letter that is an element or a member of set B is also 5/26. And looking at set C, you'll see that it has got 3 elements. So the probability for this question is simply 3/26. Pause the video again and have a go at the last 3 questions. Here are the answers. For the fourth part, let's first highlight the intersection of B and C. That's this bit here, which is the empty set. It's got no elements. So the probability that a letter chosen at random belongs to this is simply 0. For part 5, we are looking at the union of A and C now. So that is the set containing all of the members that belong to A or C or both A and C. And that is this region here. Now this region has 1, 2, 3, 4, 5, 6, 7 elements. So the probability we're looking for is 7/26. Finally, in part 6, we're looking for this region, which we already saw in question 4. You'll notice that there are 1, 2, 3, 4, 5, 6 elements or members of this particular set. So the probability is going to be 6/26.